This is the startup for week number 14. Number 1 says find the value of x. If necessary, round your answer to the nearest tenth. The figure is not drawn to scale. That is what is missing from that problem as we're reading. Now, we're told in number 1 that FG is perpendicular. FG is perpendicular to OP. What does that mean? That means that where FG and OP intersect, they form right angles. And RS is perpendicular to OQ. It also forms a right angle as well. Now, if we know that a line is coming from the center of a circle is perpendicular with a chord, then it bisects that chord. We're told that FG is 24. That means that FP is 12 and PG is 12. We also are told that RS is 36. So RQ is 18 and QS is 18. OP is equal to 10. We are asked to find X. If we know what the radius is, we can apply that same value to right here because the radii of one circle are congruent to all. Then I can find X. Now, a way that we can find the radius, and I'm going to call that little r, is by Pythagorean theorem. So therefore, we know that r squared is equal to 12 squared plus 10 squared. So r squared is equal to 144 plus 100. And r would equal the square root of 244. Which gives us 15.6 approximately. Well, I'm going to tell you right now, looking at this problem, with the number that they have given us as RS, this problem is not possible. And the reason being is this. If we sit here, and which we found, and everything we've done so far is correct, and we say that this is 15.6 as my radius, there's no way that in a right triangle the hypotenuse is shorter than one of the legs. But that is the process in which we would work it out. So the only problem with this is RS is too long. But if it were not, we would continue on. We'd use Pythagorean theorem to solve for X. That's what we'd have to do. So let's move on. Number 2, we're still finding the value of X. Find the value of X. Now, like we've already discussed, the radii of one circle is congruent to all other radii. So if this is X, that's a radius. That is X, it's a radius. Once again, if we have a line from the center of a circle, it is perpendicular to a chord. That means it bisects it. So if the whole chord is 14, this side over here is 7. So in order to solve for X, that's a tick mark, not 17. So I would say 7 squared plus 7 squared would equal X squared. I'd have to use Pythagorean theorem here. And if you recall, this is a 45, 45, 90 because that's isosceles. Two sides are the same. Correct? So we can, which we can't really use that because it says round to the nearest tenth. So let's just go ahead and go here. So we have 98 is equal to X squared, or if I take the square root of both sides, so X is equal to 9.8 or 9.9 when we round. And that is X. Number 3, let's look at it. Here we're told that WZ and XR are diameters. That means that they go from one side to the other. Find the measure of arc ZWX. So we want to know the measure of the arc of ZWX. The figure is not drawn to scale. Well, as we're told that ZW is a diameter, that means that it forms a semicircle. So if it forms a semicircle, that means that this arc right here is 180 degrees. That's just from W or ZW. But we want to go ZWX. So all we have to do is add 180 and 39 because of this angle. So 180 plus 39 gives us the measure of arc, because it's the measure, it's not the length. ZWX is equal to 219. All because we were told that WZ was a diameter. Now let's look at number 4. The measure of angle R equals 24 degrees. Find measure of angle O. The figure is not drawn to scale. So this angle here, angle R, is 24 degrees. Now that is an inscribed angle. And if we think about inscribed angles, as we have the angle NRQ, it has its intercepted arc of NQ. An inscribed angle is half of its intercepted arc, so arc NQ is 48 degrees. We found that by saying 24 times 2. The reason why we did that is because we're looking for the measure of angle O. So we want this angle in here. And if I know its arc, the measure of an intercepted arc of a central angle are the same. So angle O equals 48 degrees. Let's look at number 5 now. Given that angle DAB, so let's follow that, DAB, right angle, and DCB, right angle, and the measure of angle BDC, so B, we're looking at this angle here, is 46 degrees. What is the measure of arc CAD? Arc CAD. We want to know this entire arc. Now, with this being a right angle here, that means this is a diameter. So that's 180 degrees, correct? That's only part of our arc. We need to know the measure from C to B. And the way that we find arc from C to B is we have its inscribed angle here of CDB of 46 degrees. So that means this arc right here is 46 times 2, which gives us, not 80, 92. So then we simply add 92 and 180. So it's 272 would be our solution. Now let's look at the last one, number 6. Find the measure of angle BAC. So we want to know the measure of angle BAC. Well, AC is a diameter, right? So that means that this whole thing around here is 180 degrees. Now, if we look at our drawing, we are given a central angle. That central angle is here, 75 degrees, so that means this part of the arc, A to B, is 75 degrees. So in order to find the arc from B to C, we would say 180 minus 75, which gives us 105. But we're not asked to find this arc right in here. We're asked to find the angle. And since the Intercepted arc is 105. To find its angle, we divide by 2. So therefore, the measure of angle BAC is equal to 52.5.
How come, where is 75 happening?
So that is our startup for week number 14.
Why you divide it by 2?